Hi, everyone. Are you having a good day? Are you learning about some exciting new Spring features and projects? Since I can't see you, I'll assume that you're all nodding and saying yes. Welcome back to the Intermediate and Advanced Spring track. Our next session is about Spring Authorization Server. Many of our modern production applications require authorization in order to access various features or APIs. I'm excited to hear about how Spring Authorization Server can help us more easily handle these security concerns. Please welcome Joe Grandja and Steve Riesenberg, who will give us more information. Joe and Steve, I'll turn it over to you.
Right on. Thanks a lot, Roy. Thanks for coming out to our talk today. This is actually our first talk on Spring Authorization Server, so we're super excited about it. We're going to just kick it off with some introductions. My name is Joe Grandja. I'm on the Spring Security team, and I've been heavily focused on building out the OAuth 2 and OpenID Connect support in Spring Security over the last 4 to 5 years. Steve's presenting with me. Go ahead, Steve, introduce yourself.
Hey everyone, my name's Steve Riesenberg. Just really excited to be here. I've joined the Spring team just about 4 months ago. I've been on Spring Security with Joe, and we've been working to just continue to build out the OAuth 2 support and Spring Security. And as we're going to present today, talk a little bit about Spring Authorization Server. It's been a real blast, and I've enjoyed my time so far on the team. I enjoyed working with a lot of awesome community members, and really excited for what's coming up. So,
great, thanks a lot, Steve. I'm going to just start off with a little bit of context. As some of you are probably aware, hopefully most of you, is Spring Authorization Server went production with the 0.2 release just over a week ago, or was it 2 weeks ago? It's like time flies, but this is a huge milestone because we embarked on this OAuth rewrite about 4.5 years ago, where the Spring Security team decided that okay, we're going to rewrite the OAuth story within the Spring ecosystem. As you may be aware, the Spring Security OAuth project's been around for about 8 or 9 years. It is going to be reaching end of life this coming May of next year, May 2022. And back then, with version 5, we introduced OAuth 2 client support, version 5.1 resource server support. It expanded the client support. And it's been about a year and 4 months that we've been building out the authorization server support. So this 0.2 release is a huge milestone because ultimately it marks the completion of this rewrite, because we have reached feature parity. Whoever's using legacy OAuth or Spring Security OAuth, this is the time to migrate, because we have reached feature parity on client, resource server, and now authorization server. So feel free to start migrating over. We're going to have some questions, question period afterwards, so we'll save the questions afterwards. And yeah, let's jump right into it. So I want to just kind of, I'm going to be really quick on this slide here. This is a list of specifications that we've implemented so far in Authorization Server. There's really one thing that I wanted to point out is we're conforming to OAuth 2.1 Authorization Framework. It's still in draft mode, but this is what we're conforming to. And the one thing I really wanted to point out is OAuth 2.1 omitted a couple of the grants, the implicit grant and the resource owner password grant. We will not be providing implementations of that either. We're strictly conforming to 2.1. However, we're going to remain flexible. We've already have extension points for you to be able to, provide your own implementation of resource owner password grant if you choose to do so. However, we highly do not recommend it. There's a reason why they were omitted. There's a lot of attacks that have been performed on these two grants. So yeah, highly recommend not to do that. We just wanted to point out, because a lot of users have been asking for us to implement that, and just to point out again, we're going to be conforming to OAuth 2.1. We've implemented token revocation, token introspection. The only access token format that's currently supported is JWT, signed JWTs, as in JWS. We will be providing opaque access token support in the coming release, or within the next 2 releases for sure. And this is typically where you would use the token introspection use case to inspect an opaque token. OpenID Connect support is pretty light right now. We've implemented the authorization code grant. However, we haven't implemented the user info endpoint. It's pretty light, but this will be the focus on the next few releases. We're going to really start expanding on the OpenID Connect support. Now, if you wanted to get an idea of exactly what has been implemented, you could easily go to the repository, Spring Authorization Server repository, go to the wiki, and then here we have the feature list. This is a complete feature. This will be maintained and updated as we perform issue releases, but this is what we've implemented so far. And as you can see, there's some points here. We're going to have some sub points, as in, we haven't implemented the complete OpenID Connect Core spec because it's pretty big, right? So as we implement, we will add points here just to specify exactly what has been implemented to date. These are the upcoming features. There's actually a lot more, but these are the key ones that we've kind of outlined. So so that's that. Let's skip on to the next one here. So I want to jump into, this is all about getting started with Spring Authorization Server, and what we really got to get a good handle and grasp on are the core components. What does it take to configure the default configuration of Authorization Server? What are the required components? So I'm going to provide a kind of high level here on the slide, but I'm going to jump right into the code because it's going to be a lot more intuitive. The registered client, this is the client registration information. Without a client, the authorization server can't do anything, right? So this is obviously a required bean, as in the registered client repository. This is the service interface. This provides the CRUD operations for the domain object registered client. OAuth 2 authorization. Now this is the end result of an authorization, right? As in an authorization grant flow, whether it's client credentials or authorization code. So at the end of let's say an authorization code grant flow, an OAuth 2 authorization gets persisted into the OAuth 2 authorization service. And it ultimately contains the association of the registered client or the client that was authorized by the resource owner, right? That dual relationship, and then the end result of that is at minimum there's an access token, right? However, if it's an OpenID Connect flow, then you're going to have an access token. You may have a refresh token if it's configured, and you'll have the ID token as well stored in the OAuth 2 authorization. There's other things that are stored in the OAuth 2 authorization as well. Then we have the OAuth 2 authorization consent. If you're going through an authorization approval phase with the authorization code grant flow, this is the consent that's saved, so you don't have to re-consent every single time an authorization happens. And then we have the JWK source. This is the Nimbus API that we're leveraging. This is the provider of the keys. This is where you would configure your keys to sign the JWT, the keys that verify the signature of a JWT, and so forth. Provider settings, this is where you would configure global settings for the provider. For example, if you want to customize the authorization endpoint URI. And then we have the OAuth 2 authorization server configuration and the configure. This is the TSL and some static methods in the configuration that allow you to provide a default configuration of an authorization server. So let's actually just jump right into the code, because it's going to be a lot more intuitive looking at the code, and I could get a little bit more in depth with some of the domain object service interfaces. Let's start off where it all starts, right? Is the registered client. Okay, I mean, this is the repository interface. Pretty intuitive, right? This is ultimately typical CRUD operations, right? Here's where we save a registered client. This might happen in a dynamic client registration flow, right? And which has been implemented if you want to register a client dynamically. And here's find by ID. This is looking up the registered client by the unique identifier, or looking it up by the client identifier, right? So that's pretty self-intuitive. And this is obviously a required being. Without this, authorization server can't do anything, right? The default implementations are in memory. This is really only meant for development testing. This should not be used in production. This is just to get you up and running quickly. We have another implementation, JDBC implementation, and this could be used for production. However, there's a lot of different requirements based on your environment. You might have a different backing store that you might want to implement rather than JDBC. You might want Redis, for example. I just wanted to point this out as well. Is we're not going to be providing any other implementations other than these two, because as you can imagine, there's a ton of different types of stores, right? And Spring Authorization is in the business of application security, not data, right? So it doesn't really make sense to house these kind of implementations within Spring Authorization Server. So this would be the responsibility of the consuming application. And all you really need to do is implement this interface and register it as a bean, and that's it, right? So let's jump into the registered client and just take a look at a couple of the attributes here. I mean, obviously, we've got the client ID. This is the unique identifier, the ID. Client secret. Now, there could be a client secret. There might not be, depending on the client authentication method. If it's a public client, it would be set to none, for example, and the client secret would be null, right? But typically, you definitely want to, cater more towards confidential clients because they're more secure. I mean, but obviously there's use cases for public clients for, SPAs and so forth, for example. In those cases, you definitely want to be using Pixie. And Pixie you would set over here in your client settings, right? Here we have is require proof key. This by default, it's required. All right, so these are some settings you could set for the client. Right now we have, you could set require Pixie or require authorization consent, the consent flow. But you could also add your own custom settings in here. We're going to be adding a lot more here. And then we have token settings as well. When a token is minted for a client, what are the attributes, the default attributes of the token? Time to live for the access token. Are refresh tokens reused during a refresh flow? What's the time to live for a refresh token? What's the algorithm used to sign the ID token on an OpenID Connect flow, and so forth. Here we have, what are the supported, you could configure the supported client authentication methods. Does this client support, HTTP basic? Does it also support public, like none? We're going to be adding a couple of key client authentication methods in the next releases: mutual TLS, private key JWT, and so forth. So you could configure the supported client authentication method. Same thing with the authorization grants. Which grants can this client perform? Authorization code, client credentials, refresh token, so forth. Configure redirect URIs for redirect-based flows like the authorization code grant. What are the scopes this client can request, and so forth. So those are some of the key attributes of the registered client. Now let's jump to the authorization service. All right, so we'll open up the interface here. This is actually not required by default. In-memory authorization services instantiated. Obviously, in your production environment, you're going to want a persistent backing store. Same thing with this one. We have default implementations are the same. In-memory JDBC. All right, typical CRUD, we got save, remove, find by ID. This one, find by token. This is used in, specialized flows. If I want to introspect a token or if I want to revoke a token, that's what's coming in the request. Find me the authorization that matches this token so I could revoke it, for example, right? Now let's look at the actual domain object itself. So we have a unique identifier. We have the association for this authorization. So the unique identifier of the registered client, the principal name. So this is ultimately authentication.get name. So the unique identifier of the authenticated principal, the logged in user, right? So if I log in as Joe, this will be my principal name if I authorize client A, right? And this is what would live in this authorization. This is different though for a client credentials flow. The principal name would be the client ID, right? But there's always that association, right? And then here we have the authorization grant type. What was the flow that was realized for this authorization? And then we have tokens, right? A map of tokens. As I was mentioning earlier, if this was an OpenID Connect flow, then this map would consist at a minimum the access token and the ID token, and potentially the refresh token if it's configured for this particular client. And then we have attributes. Attributes are, depending on the flow for the authorization code grant, we'll have the authorization request will be stored in there. We'll need that when we're doing PXE validation, for example. If there's a approval phase, then what will be stored here is what the user consented to for the client, as in the scopes and so forth. So that's the authorization domain object. And then we'll jump to the authorization consent service. I'm going to skim through this one kind of quickly. Typical CRUD, there's consistency, as you can see, between the three service interfaces that I've been showing you. And this is a pretty simplified one, right? So the association, once again, the registered client ID, the principal name, and then the authorities, right? So during the consent flow, your typical, consent screen is, do you authorize this client to access your profile information, your email, right? So this would be, in here, the granted authority would represent those logical names, right? And we want to keep this generic because this could either be scopes or it could be claims, because what I just mentioned were profile and email. Email is just, one claim. Profile is, let's say an aggregation of a number of claims, right? So we want to keep this flexible because you might want to have more finer grained consents to specific pieces of data, right? So that's why it's called authorities there rather than scopes. And then I'm going to skim through this one really quickly, but ultimately we're using Nimbus's API GWK source, and this is the provider of the keys, right? Ultimately, you need to supply the application with the signing key, and the verification key, whether it's RSA or elliptic curve, using Java Security API, and then you transform that to the JW or the Nimbus's representation of that. Here, I'm going to share this branch with you guys afterwards, so you could easily take a look at the code. But basically, you're transforming it to Nimbus's representation and then passing into the JWK set. Really, this is going to be standard for all. You just got to supply the key wherever that's coming from, key store, your environment, whatever the source is. And then provider settings, I could set a few different things here, right? I could customize the authorization endpoint. I could customize the token endpoint, token inspection endpoint, and so forth. This default, I'm setting the issuer here. So what this is ultimately doing is it's enabling the provider configuration endpoint. So if I jump up to here now, this is how I would configure the default configuration for authorization server, right? The absolute defaults. Ultimately, what I'm going to do is I'm going to auto-wire HP security, and then I'm going to call this static method on the OAuth2 authorization server configuration. And what this ultimately does is sets up the default configuration. And these are the default endpoints that it sets up. So obviously the authorization endpoint and token endpoint, token revocation inspection, JWK sent endpoint, so the resource server could fetch the keys for verifying, and ultimately the client as well could fetch the keys to validate the ID token signature. Because I set the issuer down there, it automatically enabled these two endpoints. So the standard OAuth2 authorization server metadata endpoint and the OpenID Connect provider configuration endpoint. And these are the endpoints that clients and resource servers would use to fetch the provider information to self-configure itself. So that's a bit of a whirlwind there, but those are really the core components you should be familiar with, and the default, how to configure Spring Authorization Server defaults. Now, if I jump back into here, I'm going to hand this over now to Steve. He's going to expand on how can we customize Spring Authorization Server right now.
All right. Thanks, Joe. Let me share my screen here. And so as Joe mentioned, we're going to focus on customizing this authorization server. And I'll just focus on one point, which is customizing the authorization endpoint today. And so what I have here is that configuration class that Joe showed that you can call apply default security to get started if you want to ship with kind of the default setup. What I'm going to do, though, is show that I can actually copy and paste this code, and it's totally fine to do that into my own config class. And so I've actually prepared that ahead of time here. And in addition to copying that code into my own security filter chain bean, what I've done is I've added some calls to the configurer that ships with Spring Authorization Server. And so I'm just showing you that we can call the authorization endpoint here, and Joe showed that you can customize other things like the token endpoint and so on. And here's what you can do with the authorization endpoint. So we can do things like set the authorization response handler. And so normally the authorization code flow would redirect back to a client. And this is how you could customize that. And there will be a commit in the repo that we'll share at the end where I show you how to actually switch this out to be a form post. And so that's one option. And there are a number of other things you can do, like set the consent page. You can actually override the error response handler that's used. And you can even customize the request converter that feeds into the provider. But I'm just going to focus on the authentication provider. And so I've created my own custom one here. And so we jump down. And in fact, I say custom, but I'm actually using the default class that ships with Spring Authorization Server. And so it's the OAuth 2 authorization code request authentication provider, which is quite a mouthful. But all I'm doing is creating that with those default service interfaces that Joe shared with us, the repository, the authorization service, and the consent service. But in addition, I'm just going to set one thing. And from here on, we'll just focus on this, which is the authentication validator resolver. And so this allows us to customize a couple of things currently in main, and that is the redirect URI and scope parameters. So we could swap out the validation that Spring Authorization Server sets up for us automatically with our own custom one. We get a lot of questions, for example, about what happens when I want to use localhost in development. And so this is where you might want to start looking to customize that. And hopefully you'd say, well, I'm going to do this in a dev profile. I'll set up my own custom redirect URI, but in prod, we're going to use the one that ships with Spring Authorization Server. But however you do that, you can provide your own validator. And so I've done that here. And I have this validator that you might think is harmless. It's just going to do a regular expression match on the redirect URI. But what I'm going to show, we're going to have a little bit of fun here, and I'm going to role play as an attacker. And we're going to see what happens when we begin to customize some of these things. And if we weaken our security posture a little bit, thinking that, it should be fine to be a little bit more flexible than the spec allows for, what can go wrong with that? So I've started a couple of applications here. And I have this application called Honest SSO. So this single sign-on provider is implemented using Spring Authorization Server, and it's not attempting to do harm. They're one of the good guys. They don't have any bad intention. However, there is this other single sign-on provider, or at least it calls itself one, and I'm going to call it Evil SSO. And Evil SSO, unbeknownst to everybody else in this stack here, is compromised by an attacker. So let's say it was a website that at one point was good, and somehow it's become compromised. And then I have Honest Client, which we're going to jump to the UI for. And this is just a fake OAuth client. Don't copy any of this code and put it in production. It's not intended to be useful, except for demonstration purposes. But you can check out the repo at the end to see this in action. And so here's the UI that I have. It's pretty basic. We just have two links. We have an Honest link that's going to take me to a page where I can launch the OpenID Connect flow for Honest SSO. And I'm not going to show you that because that's going to act pretty much consistently with what you'd expect. But instead, let's go ahead and switch over to the Evil page and see what happens when we launch a flow to that SSO that's been compromised. And this attacker, I'm going to role play that attacker, but this attacker has been watching us and probing our defenses. And so this is me kind of experimenting with my hack and seeing if I can get this working. So I'm going to click on this link here. And what I've done is set it up so that we're going to redirect immediately when you launch my Evil website. And instead of showing you a login page for Evil, I'm going to show you a login page for Honest. And all I've done is I've placed my own spoofed redirect URI in the location header in that redirect. And then I've swapped out the client ID so that it looks like it's Honest client instead of Evil client. And so with that, the user may or may not notice that they're actually at Honest SSO. And if they don't notice, they might be tempted to log in. So we'll see what happens when we do that. And I get this consent page. And again, if I'm a typical user, I may or may not notice what's going on. I may not notice that this says Honest client, or maybe I don't even know what that means. And so we'll just blindly accept the consent. And so what's going to happen here? Well, we're going to get redirected back to the attacker's website instead of going back to the client. And that's because we've chosen to really weaken the security of that redirect URI validation. And so I've done that, and the attacker just says, hey, I have your code, goodbye. And so we've been hacked, and our authorization code has actually been leaked over to the attacker's website. Okay, so that's not great, obviously. So probably that was a pretty naive implementation of our redirect URI validation. And so just to show you, maybe a trivial but still more secure implementation would use strict equality for that string matching algorithm. And this is the recommended starting point. If you're going to customize this, always do strict matching on that redirect URI. And then you can kind of, for example, maybe you can disable the localhost validation when you're in a dev environment, but make sure it's on when you're in production. Okay, so that's an attack against our authorization server. And if we fix that, I'm going to hop over to another commit here that I've prepared that shows another attack. And this attack would be when the attacker kind of watches us and sees that we've shored up our defense on the authorization server, he's going to turn his attention over to the client. And so let's see what happens when he does that. So I started up the applications again, and I'm going to go back, and we're just going to go back to our home page, and I'm going to focus on the Evil flow again. Again, Honest would work as you expect. But now what the attacker is going to do is they're going to use the legitimate redirect URI. And so I've just placed that here in the location header. So instead of redirecting back to my Evil website, the user that is not paying attention and ends up actually signing into the wrong single sign-on provider is actually going to go back to the legitimate client. But what I've done is I've actually specified a single endpoint that's going to be redirected back to, and it's just /authorized. And again, you might think that's harmless, but in our example, we have 2 single sign-on providers that we've integrated with in this client. And so because of that, we can't tell as the client which of those 2 providers redirects back to us. So let's see what happens. So I'm going to log in here as myself again, and I'm just testing my own hack to make sure it's working. And what I'm going to do is I'm going to pause the flow in the middle. And so before the redirect actually hits the client, now in this case, I'm cheating. It actually has hit the client, and I'm just showing you a fake page here. But use your imagination that I'm using a tool that kind of intercepts the response, and I can kind of play with things here and see whether or not my attack is working. And so in this case, I can see that the client thinks that this authorization code belongs to what it's calling Evil client, which is actually a registration with Evil SSO. And so what the client's going to do is it's just going to hand this authorization code over to the attacker. And so if that was the case, then again, we'd see that we've been hacked, or this poor user has been hacked, and the authorization code has been stolen. So how would the attacker use this? So let's see what happens. I'm going to jump to yet one more commit. And by the way, that attack was called a mix-up attack, and you can kind of check out the best practices document that the OAuth community has authored to learn more about that, and that's kind of directly where I'm taking this from. The next attack, though, that would build on that is called an authorization code injection attack. And so what this is now that I've figured out that I can get an authorization code, the attacker wants to know how they can use that. And so let me restart my applications one more time here. And in this flow, we're going to actually figure out a way to get an access token. And in this case, we're going to try and get an access token associated with a session that we own, we being the attacker. And that access token in that session is going to belong to a victim. And so that's what it means to say authorization code injection. So one more time, we're going to head over to our client here. And actually, I need two browsers because I need a victim and an attacker. So first, I'm going to log in using that same link that the client supports to go over to Evil, which has been compromised. And I'm just going to log in as our poor victim, Joe, here for a second. And so Joe is going to, Joe probably would read the consent screen. He knows well enough to do that. But let's just pretend that he doesn't, like a typical user might not. And he just blindly accepts that. And again, I've paused the flow in the middle. And what we're going to do is we're going to actually watch what happens when the client requests an access token from what it thinks is the right provider. And that's Evil. Well, I have your code, says the provider, you may leave now. In fact, the provider has spoofed this as the access token. That hacked server can actually return whatever it wants because now it has the code. And so as the attacker, I'm going to hop over and grab that code that I've printed out to my console. And if I'm quick, as the attacker, I can now go ahead and inject this into my own session. So let's do that. So in this case, I'm going to log in as the legitimate user, and I have my own account with the client. And so I'm going to do that. I'm logging in as me. Again, I'm just going to skip past the consent screen here, and nothing's funny up to this point. But here I've intercepted the flow, and I'm going to go ahead and put my own, or this stolen authorization code into my session. And when I do that, I can let the rest of the authorization code flow proceed as normal. And in this case, now my session has an access token. But who does this access token belong to? It doesn't belong to me. And I'll just show you by decoding the token here that, in fact, this access token belongs to Joe. So I've actually now compromised a session that is on the client, and whatever the client can do with Joe's access token, I can now do. And again, it probably wouldn't be typical for me to actually see the access token as the attacker, but I don't need to. I can do whatever this client could do now as Joe. And just a couple of points that I'll make. I was glossing over a few security features that you might know exist in these flows. For example, the state parameter or the nonce parameter, or another recommendation that the community makes, which is that you can actually use Pixie to do request forgery protection as well. I've glossed over those, but we're just assuming that the attacker is smart enough to figure out how to bypass those protections. And even if they can't, we can see that if there's one notch in our security chain, then we are vulnerable to something, and maybe the attacker can use that to kind of bootstrap their attacks and build more and more sophisticated attacks. So what's the point here? Well, just briefly in the last amount of time that I have, I'll show you that if we don't follow some of the weaker security postures that I set up in that example, and we do some of the things that are recommended as best practices, for example, setting a unique redirect URI for this client so that I know that when this redirect comes back, it comes back from the relationship between me, the client, and the authorization server, Honest SSO, that it's coming from that provider, then that will help me avoid this attack and many others. And so there's a number of other best practices that you can research, and maybe we'll provide a link to that best practice document towards the end or over in the Q&A section. But I'll just show you that this attack would not have proceeded if we had had just that one basic protection in place. And so I'm going to go, and again, I'm going to follow as Joe, the evil link here. And Joe, as the victim, is going to sign in like normal. He doesn't know that he's signing into the wrong provider. But now the client and the provider, in this case, Spring Authorization Server, have a contract together, and they can together participate in this to make sure that we can detect this attack. And so the client, in this case, it really is up to the client to say, hey, I know that the authorization server validated this redirect URI. I can trust it, and I can see that this came from evil client, not from the legitimate one. And so we've stopped the attacker. Okay, so that was a lot. I'm going to turn it back over to Joe, and Joe's going to share with us a little bit about mutual TLS and how to customize client authentication. And you're muted, Joe. Can we unmute Joe?
Can you hear me now? Okay.
Yep, you're good.
Yeah, I lost my controls. They kind of got lost there. Steve, thanks a lot. That was awesome. That was awesome. Um, all right. So let's jump to customizing client authentication, right? This is definitely a very important piece that an application should be able to customize if you want to add your own custom client authentication method. Currently, HTTP basic, client secret post, and public client authentication is supported with 0.2. Like I mentioned earlier, we're definitely going to be expanding. It's going to be a major theme in the next 2 releases is implementing more secure client authentication methods, specifically using asymmetric key encryption, such as mutual TLS and private key JWT. Those are coming definitely in the next release, next couple of releases. The next release will be mutual TLS client authentication. This is a very, very important one. The mutual TLS client authentication and certificate bound access token specification is definitely a critical, very important specification that we will be providing in the next release. What this ultimately does is it prevents token replay attacks. How does it do that? Well, when a client authenticates using mutual TLS, right, the authorization server ultimately has the client certificate, right? And the authorization server could then compute unique identifier, for example, SHA-256 thumbprint of the client certificate, and then add that value as a claim in the JWT access token. Right, so it's that access token is bound to that client certificate, hence bound to that client. So only that client could use that access token. However, the check still needs to be applied on the resource server side. So the resource server side, when it authenticates the JWT, ensures the signature is valid, ensures it's not expired, it does this additional check, right? The client also connects with the resource server using mutual TLS. The resource server grabs the client certificate, computes the thumbprint, and then compares, right? And obviously, if it's equal, it proceeds with the access request. If it's not, rejects it. Right. So this is huge because a bearer access token, if an access token is leaked, anybody could use it. It's a bearer token. The holder of the token could call that same resource server and fetch those resources, right? But using a client certificate bound access token, this prevents this token replay. So let's get into it. Let's get into that. So before I even get into the sample, this sample, honestly, it was pretty complicated. There was a lot involved. PKI is pretty complicated setting it up. Anybody who's, in operations setting up the PK infrastructure, there's a lot involved, right? So I'm going to just provide a high level of what I've set up here. I'm not going to get into the details of how I set up these certificates. Everything's in the repo. There's complete instructions and details. You could easily look at the details, after our talk, but I'm just going to give a high level. This is what I've set up. Right. So ultimately, what I wanted in this application setup is I wanted all the communication to be mutual TLS. Right. So client to the authorization server, client to the resource server, mutual TLS. Also, the resource server to the authorization server, I also want that to be mutual TLS because the resource server ultimately has to fetch the public keys in order to be able to validate the JWTs that are incoming. So this is what I wanted to set. This is what I want to set up. And I'm using the PKI method. I could use the self-signed certificate method, but I decided to go with the PKI method. This is the hierarchy that I've set up. So I have the Spring root CA, who basically it's acting as the certificate authority. This is the root certificate. You got CN there as in the common name, right? Each certificate has a distinguished name, a unique identifier of the subject of the certificate. So here I've given it the name Spring root CA. And then I got 3 other client certificates. So I got my OAuth client application, I got the authorization server application, and resource server application. Those are the common names, right? So the certificate chain looks exactly like this. So when the client connects with the authorization server using mutual TLS, the incoming certificate that the authorization server sees is this chain, right? The root certificate is Spring Root CA, and then obviously the client certificate Spring Client, right? So that's what I've set up initially. Let's jump into the code and just kind of get into the details of how this is ultimately set up. So we're going to go back into the DSL and the authorization server configurer, right? So this is the root of the DSL. We have the client authentication DSL. So this is where you would configure custom client authentication methods. What I've configured here is an X509 client certificate authentication converter and the associated provider. Right, so I've technically overridden the defaults. So this sample only allows mutual TLS, does not allow HTTP basic, post, or public clients. So this is pretty tight, this sample, right, as far as your security posture. Let's take a look at this. How does this implementation look like? Now, as I mentioned, I'm not going to go into the details of how I set up these key stores or the generated certificates and the key stores. But just to point out quickly, in this repo, we have a bunch of commands here, key tool commands that basically set everything up. So you could easily take a look at this. And ultimately what that generated is my key store files for all my different applications, right? This is the key store file, the P12 file. This ultimately contains the private key, the X509 certificate, and associated public key, and it also contains the trusted certificate, which is Spring Root CA, right? So each of the applications trust Spring Root CA. So we got to add that as a trusted certificate in there. So the SSL handshake, ultimately verifies because everyone trusts Spring Root CA, right? So when that SSL handshake completes or goes up the chain validation, goes up the chain to validate, they both trust Spring Root CA, SSL handshake completes. And then eventually it comes into here, into this converter. And this is what we're doing. We're trying to extract the client certificate. After the SSL handshake is complete, the certificate is stored in this well-known attribute on the HTTP servlet request. We extract the certificate. We're getting the first one because there could be multiple because of the chain. The first one is the client certificate. We're extracting that, and that's pretty much it. Like, there's some other details here, but ultimately we're returning the OAuth 2 client authentication token. We're passing the client identifier, the authentication method used, and then the credential, which is the client certificate. So that's pretty simple implementation, right? And then we'll look at the authentication provider. This is ultimately what's called, subsequently. Cast into the client authentication. We get the client ID first, right? And then we're going to look up the registered clients, right? And then this is the key point that I wanted to, show here. But actually, even before I get to this, I forgot to show this other configuration that I added here. So basically, it's the converter, the provider, and then I also got to configure my client, right? So I changed my initial client from client secret post to TLS client. That's the only authentication method it supports. But then I have this special setting here, right? As I mentioned earlier, you could add custom settings to client settings. And that's what I've done here. It's by default, the prefix is settings.client. And then I've added this logical name, X509 certificate subject DN, distinguished names. So this is the distinguished name of that client certificate for the OAuth 2 client application, right? Common name Spring Client, organization Spring, VMware US, right? So this is ultimately what would be registered by the client, its unique identifier or the subject DN of the client certificate. So I'm going to use that here in the provider, right? So the incoming certificate, I receive the incoming certificate over here, and then I do the comparison. I get the subject DN on the incoming certificate, and I compare it to the subject DN that's registered with the client. If it passes, then I proceed, right? The SSL handshake happened because I'm here, but the extra validation is the comparison of the subject DN that's registered with the client with the incoming certificate, right? So that's the setup. So there we go. So that's literally setting up mutual TLS side. Now what's the next step as far as binding that certificate to the access token? What did I have to do to the configuration? Okay, so I'm going through this flow. The client's going through the flow. It's calling token endpoint. It authenticated using mutual TLS. It proceeds to, let's call it the authorization code grant. That's the flow that we're in, right? So ultimately, I'm going to go to the authorization code grant authentication provider. We're about to mint the token. I want to customize that token, right? I want to add the client certificate to the token. So this is what we would do. We would add an OAuth token customizer bean. There could be different OAuth token customizers depending on the token format. Currently, we only support JWT, but in the future or in the next release, we're going to support opaque tokens, right? So the context is going to be different in that case. In this case, it's JWTs. So this is the context for the JWT encoding context, right? Provides relevant information to the specific flow that's currently active, right? In this case, the authorization code grant flow. So there's going to be different things I could access from here. For example, the registered client, the current authorization, the currently authenticated client, the authorization code grant parameters, and so forth. But all I just need the client authentication principal. Right. I want to do a check also. I'm only looking to add this for access tokens. I'm not looking to add this into ID tokens or refresh tokens. So I do that check first. Then I obtain the client authentication. Then I'm able to obviously get the X509 certificate. I compute the thumbprint, and then I add it into this custom claim. All right. So now I've added this to the custom claim. Now, ultimately, this access token is bound to this client, right? So I've completed that part, right? And now the only other part that I need to do is on the resource server side. The resource server side needs to look this up and do the same comparison that that the authorization server does, the same comparison, right, to enforce the sender constrained access token, right? So let's figure that out. But even before we even do that, let me, I think I got everything started up here. Let me double check. I'm just going to run through the sample just to show you that everything's working, right? And then I'm going to add that code that enforces the check, and then you'll see that it's going to fail. And then we're going to introspect it and take a look at the code there. So let's just jump in here. Log in. We're going to do the client credentials grant. I'm just going to open up the debug window. So I'm going to get the token here. Okay. So this is a specific client. This client, this registered client has an access token now. I'm going to basically simulate replaying that same token, but from another client. So I have another client set up with its own certificate, and I'm just going to simulate that client using the token of the other client and ultimately replaying it, right? Now I've replayed it, right? I've passed that token because ultimately it's just a bearer token, right? If it was leaked, this malicious client could replay it and get the resources, so I'm just kind of simulating that there. Now let's see what happens when we actually enforce the check on the resource server side. I'm just gonna check this out, and then I'm gonna restart the resource server, and then I'm gonna try that again and see what happens. Actually, even before that, I'm going to put, well, I'll put a breakpoint after. Let's just refresh this there, right? So it failed, right? Now let's take a look at the code, right? Like let's look at what did we have to do on the resource server side to enforce this. Let's go to our resource server config. Then I'll put a breakpoint, but let's look at the configuration first. So we got to define a GWT decoder, right? So the resource server could decode the GWT, ultimately authenticate it, as in verify the signature, make sure it's not expired, but we want to do an additional check, right? This is some boiler template. This is basically setting up the key store for the resource server, because ultimately the resource server does call the authorization server to be able to do the mutual TLS connection. But this is the main thing that I wanted to point out, right? I could add different OAuth 2 token validators. So I added this one, right? This X509 client certificate claim validator, right? I'm going to run that again, and we're going to just kind of inspect this code and take a look at it. So I'll run this. Okay, so we're here now. I'm going to compute this thumbprint. This is where the check fails, right? Now, if I just kind of, hopefully everyone could see this. This is a thumbprint that it computed. And let's look at the X509 certificate. As you can see here, the incoming one, as you can see here, the CN is token replay client. It's a different client, right? Different client certificate. You know, this token was assigned to the Spring client, right? So we could see that it's the token replay client certificate. And the thumbprint here versus thumbprint in the JWT, that's token value. Go to the claims here. As you can see, I'll do that. They're different, right? That's the thumbprint in the JWT. This is the thumbprint of the incoming access token. As you can see, it's different, and it basically fails, right? So that's a pretty simple implementation, right? I'm extracting the certificate, computing it, and fails. So this pretty much completes the demo and what you can do to protect yourself against a token replay attack. This is definitely coming in the next release, this implementation of mutual TLS client authentication certificate bound access tokens. So definitely keep an eye out on that. Let's jump to, yeah, I got 5 minutes there. So we're actually spot on with time. OpenID Connect Core, like right now, it's pretty light in features. We've implemented the authorization code grant flow. User info endpoint is not implemented. There is quite a bit in OpenID Connect Core, and we're going to be expanding on this. This will be our focus in the next few releases. We're going to be building out the support here. We got a really solid base with the OAuth 2.1 core. Now we're going to start building OpenID Connect Core features as well. As I mentioned, we're gonna focus on providing, asymmetric key client authentication implementations, specifically private key JWT, mutual TLS, and this one too, resource indicators for OAuth 2. This is also a really important specification. This ultimately provides more finer grained control, access control on the resource server side. So I could do with this implementation, I could do the same thing on the resource server side. If the authorization server computed the thumbprint of the resource server certificate and added that to the audience claim, then the resource server certificate could do that same comparison. And ultimately what it's doing is I'm only going to accept this access token if it's meant for me, this resource server, right? So once again, just tighter security control. So this is going to be a big one as well. And that pretty much wraps it up. There's a link there to the Spring Authorization Server repo, our branches there. And thank you so much for coming out. Hope you guys enjoyed it.
Thanks, everyone.
So what we're gonna do right now is we're gonna jump into the Q&A room, and we hope to see you there, and we'll answer all your questions. All right, Steve, let's jump in there.
All right, thanks, guys.
Thanks, everyone.
Thank you, Joe and Steve, for that great introduction and overview of Spring Authorization Server. And Steve, welcome again to the Spring team. We're glad to have you working on the project. Thanks to our attendees for joining us for this session. If you have any questions or feedback, please join Joe and Steve in the QA room, as they just discussed. Coming up next in our next session, Jens Schauder will present how to accomplish some of the less obvious features of Spring Data JDBC. We'll see you there.